All right, so little change of plans on. We're going to wait and do the last theorem tomorrow and give a little more work time today, packet wise, and then also I wanted to go over some of sample two because we didn't really get a chance for you to ask some questions on that, so you might get that sample two out here eventually. But just talking about the two theorems, okay? So we had the extreme value theorem, which says there's both a max and a min, and Charlie and I had discussed this morning about. The question was, can these two theorems we learned ever be contradicted? And the answer is what? No, they cannot be contradicted. To be contradicted would mean that you had a function that was continuous and on a closed interval, and it didn't have a max and a min. That would contradict the theorem. Not going to happen, right? These are proven, at least with the information we have right now, nobody has been able to disprove these two theorems. And so that is what they say. So any question that says, what does the intermediate value theorem say about this situation? We had some questions like that, right? What does the intermediate value theorem say about this situation? Well, it's going to say one of two things. It's either going to say it hits all the y values between the endpoints, or it's going to say nothing, right? You're either going to get the car, the promise will be kept, and you'll get the car, if you get the A. If you don't get the A, then the promise says nothing. Maybe you get the car, maybe you don't.
Did you get a haircut recently?
Several days ago. It's a little upsetting, you just noticed. That's all it is.
Has anybody else commented?
Well, that's true. Nobody else has commented either. But, it's kind of like.
I bet my ex didn't lose.
I didn't.
I thought about getting one like that picture, his old picture.
That gross. Couldn't cut it to be a nice.
Actually, Cody, I just got cut last night. So.
How does the extreme value theorem work with a horizontal line?
Good question. Horizontal line. Said, is a horizontal line continuous? Closed interval. Right? Extreme value theorem says there's both a max and a min. Let's say this is a y value of 4 here, right? Let's say this is y equals 4. What's the max of that function? 4. What's the minimum? 4, right? Because y is 4 the max. Is there any values bigger? Nope. So 4 is the max. Are there any values little? Nope. So 4 is the min, right? So that's a good question. It comes up just about every year, but I'm glad you're thinking there because, but there still is a max and min. Okay. All right. So back to this. So the theorems either say what their conclusion says. So the extreme value theorem either says there's a max and a min, or it says nothing. Right? If the hypothesis is there, if the function's continuous and there's a closed interval, then the function is going to have a max and a min. That's what the extreme value theorem will say. If it's not continuous or it's not a closed interval, then the extreme value theorem says nothing. Okay? It says nothing. All right, so I can go through these fairly quickly, but in some detail. So, because a big part of next Tuesday's quiz. So what do we got? We got the take-home, which I'm going to give you at the end of the period today, and it is actually due on Tuesday. But I said a good idea would be to work hard on that over the weekend. So that's why I'm going to give you some packet work time today, because as you get into the weekend, maybe some packet stuff, but you're probably going to focus more on the take-home. You get to Monday, then we'll really be focused on the quiz, kind of, and maybe still working in the packets a little bit. And then you're trying to finish up the take-home, but hopefully that's pretty much done. And that's kind of we still got that going on. And then Wednesday, Thursday, we can come back to the last of the packets and really kind of focus then towards the midterm. So we got juggling several things at once here. And so that's why I kind of give you a lot of time to concentrate on the packets today. But before we do that, you'll really kind of go through this part, because the quiz on Tuesday, a lot of it will be about these theorems. A lot of it will be questions like this, some true falses, some what does this theorem say, So very similar to some of the questions you're seeing today, are potential quiz questions. So right, it's a no calculator, it's more about the concepts and the ideas, and that's what these questions were about. Okay, so first of all, I just talked about where is this function continuous. Now, I'm not going to quiz you on Tuesday about the definition of continuous, but it's something we've done before and we should know. And remember, there were 3 parts. To be continuous at point A, f of A must exist or must be defined. There must be an output. Okay, the limit as x approaches A of the function must exist. And then those 2 things must be the same. Those were the 3 things you needed to be continuous. So if you look at this function, this is not continuous right here, right? Now why? Well, the limit exists, right? The cars meet right here. The function exists right here, but they're not the same. So that violates number 3. So if this is 1, 2, and then 3, these have to be equal. These 2 parts have to be equal. Then it violates number 3. Right here, the limit doesn't exist. The cars don't meet. Right here, the limit doesn't exist. Right here, the cars meet, so the limit exists, and the function's defined, but they're not equal. So again, it violates number 3. And then right here, the limit doesn't exist. Okay, over to this one, limit doesn't exist, so it's discontinuous. Right here, the cars meet, the limit exists, function's defined, but they're not equal. And then here's the only one that violates just number 1. Right here, the function has no output. It's not defined. And so that's why it's discontinuous. Now, for us, it's wherever there's a gap or a hole or a break or whatever, a jump, that kind of thing. That's where it's discontinuous. But by mathematical terms, it's those 3 things right there that causes it to be discontinuous. So you would just say -4 to -3. Don't include -3. From -3 to -1, that kind of thing. That's where it's continuous. All right, moving on. Number 7. Does the conclusion for the IVT hold here? Well, the IVT says that it's going to hit all the y values in between the endpoints. And so which y values does it have to hit? The y value. What are you looking at on F? I can't emphasize this enough. We're looking at the y values between what and what? The y values between -2 and 1. It's got to hit all the y values between -2 and 1 if the intermediate value theorem conclusion is going to hold. Now, clearly, the intermediate value theorem does not promise this will happen, right? Because this function is what? Discontinuous. This function is not continuous, clearly. So the intermediate value theorem does not have to hold. But it could, right? You don't get an A, you might get the car. Function not continuous, it might still. But what you got to understand is the intermediate value theorem says it's going to hit the y values between the endpoints. Here's the left endpoint, here's the right endpoint. We're not doing max and min here. That's not what this is about. It's about the left endpoint, the right endpoint. So -2 to 1, it's got to hit all those y values. Does it? I think it does. I think it hits all those y values. Okay, so we get lucky. We got the car, but we wouldn't have had to. What if this blue dot wasn't here? Right here? Never works. I always try to cover that. What if that blue dot wasn't there? Would it hit all the y values? Then it never hits -1 because there's a hole there, there's a hole there, right? If this blue dot wasn't there, then we'd say, no, it didn't hold. There's no y value at -1, okay? But it's fine. It didn't break the promise. It doesn't violate the intermediate value theorem because it doesn't promise. Okay, what about the other one? What y values, to satisfy the conclusion of the intermediate value theorem, we'd have to hit what y values between what and what? 0 and 2. Here's the left endpoint, here's the right endpoint. So between 0 and 2, we would have to hit all those y values. It looks like it does. It hits them all. Okay, so it does hold there. Number 9, does the extreme value theorem hold? The extreme value theorem says what? Max and min. Is there both a max and a min here? Min here, max up here, right? Is there a max and min here? There's no min, is there? There's no min, right? This is what we talked about yesterday. -2, no, it doesn't exist. -1.9, 1.999, right? There's no min. So the conclusion does hold here. Here we do get the car, even though we didn't get the A. Here we don't get the car, right? All right. So the next question. I showed you this yesterday. All has to do with this function right here, 1 over x. Okay, what does the extreme value theorem say on the interval 0.1 to 1? Here would be 0.1 right here, and that would have a value of 10 up here. Okay, 1 over 1/10 would be 10. What does the extreme value theorem say on this interval? Quickly. There's both a max and a min, right? That's the only thing the extreme value theorem will ever say. The extreme value theorem will say there's both a max and a min, or it will say nothing, right? why does this say that there is both a max and a min? Why are those, you always need to include, if you say, hey, the extreme value theorem guarantees us here there's a max and min, you better include that it does satisfy the hypotheses, right? What are the two that it has to satisfy? This function is continuous and closed interval, 0.1 to 1. There's a closed interval and it's continuous between 0.1 and 1, right? From here to here. So there has to be both a max and a min. Okay? Number 12. Although f is continuous from 1 to infinity, it has no minimum value on this interval. Why doesn't this contradict the extreme value theorem? So from 1 on out to infinity, it does not have a minimum. Why doesn't that contradict? It's not a closed interval. It's got to have both those parts, right? It's not a closed interval. Okay? Although f is continuous from 0 to 1, it has no max value. Not a closed interval. 14. What does the extreme value theorem say about f on the interval 0 to 1? They say, okay, let's close the interval. Let's go 0 to 1, close the interval. What does the extreme value theorem, or excuse me, what does the extreme value theorem say there? Nothing, because it's not continuous from 0 to 1. Why? It's undefined at 0. It's undefined at 0, right? So you close the interval from 0 to 1, and all of a sudden you don't have an output at 0 now, so therefore it's not continuous. And so it doesn't meet those, and so the extreme value theorem says nothing. 15, although this is what we did with Newton's method. So you plug in -1, you get -1. You plug in 1, you get 1. Oh, so if I plug in -1, and then I plug in 1, I have to hit all those y values in between, so this graph should cross the x-axis somewhere. That's what it's saying. Oh, but it never does. That's what it's saying. It says you plug in at -1, get -1, you plug in 1 and get 1, but there's no place where it equals 0. Why doesn't this contradict? Because not continuous, right? It's not continuous between -1 and 1. So therefore, it doesn't have to cross all of the y values from -1 to 1. Okay? Which this one clearly doesn't. Not continuous. All right. 16. Show that the intermediate value theorem holds on 0.1 to 1 and y equals 5. Well, first of all, should it hold? From 0.1 to 1, oh, that's this piece right here. Is it continuous? Closed interval? So we should hit every y value between 1 and 10, right? Now, do we? You have to show that it works for 5. So what'd you do? A few of you had questions on this one. What do you do? How do you show? How do you show that y is equal to 5? Plug it in. Plug it in. Y equals 1 over x. Plug it in. So just show 5, solve it, right? So 5x equals 1, x equals 1/5, which would be 0.2, right? Let's remind ourselves what the intermediate value theorem actually says, the part you're going to have to memorize, right? Now I keep saying we got to hit all the y values. That's not what you need to say when you're stating the intermediate value theorem. The intermediate value theorem says, let k be any value between f of a and f of b. Now what are f of a and f of b in this problem? Not 0.1 and 1, that's a and b. 1 and 10, f of a and f of b are the outputs. So f of a and f of b are 1 and 10. So let k be any value between f of a and f of b. So let k be any value between 1 and 10. So I picked one, 5. There has to be some c between 0.1 and 1 that equals 5. So how do we show that? You find it. So you just set the function equal to 5, the output of 5, and show that it gives you an x value that's between 0.1 and 1. So since it gave us 0.2, that's between 0.1 and 1. That's how you show. Okay? But, okay, let me say that again. So let k be, so the key to that is I could let k be any value in between here. I could let k be any value between 1 and 10, and I could find an x value that would give it between 0.1 and 1 that would give me that value. Let k be 7.37648. Set that equal to 1 over x. I can find an x value that would give you that out. Okay? So what that means, it's going to hit every y value in between them, because I can take any one I want, and I can find an x that will go with it that's in that interval. That's what it says. Okay? So that's how you show. So that could be on there. That could be on the quiz. Okay. All right. Use the intermediate value. Oh, we skipped 17, didn't we? Okay, 18. So at midnight it's 13 degrees. At 6 a.m. it's risen to 15 degrees. What does the intermediate value theorem say? Well, you had to hit every temperature between 13 and 15. You had to hit every temperature between 13 and 15 during those 6 hours. Okay? Now it says, and again, I said this earlier, show why the conditions exist. Well, it's continuous. Temperature is a continuous function. It's not going to jump from one temp to another, right? Temperature is continuous, and we got a closed interval, maybe to 6 a.m. or midnight to 6 a.m. So it's a closed interval. So that's you would have to add that in there. Okay. Must there be a time between midnight and 6 that it was 10 degrees? Must there be a time that was 10 degrees? Could it have been 10? Okay. I go from Kearney to Grand Island on Highway 30. I have to go through Shelton, but I don't have to go through Elm Creek. But could I? Could have went through Elm Creek, but I wouldn't have to. But I have to go through Shelton, have to go through Gibbon, I have to hit all those points in between. Okay? Must there be a time between midnight and 6 when it's an integer multiple of pi? Kind of a weird question, but the answer is no, because 4 pi is less than 13, and 5 pi is more than 15. And so there is no temperature between 13 and 15 that's an integer multiple of pi. What does the extreme value theorem say here? There's got to be a maximum in temp. I mean, that it says that or nothing, but the conditions are fulfilled. We said it's a continuous function on a closed interval. So the extreme value theorem says there has to be a max temp and there has to be a minimum temp. Could the temperature have been 25 degrees? Could have been. Could have been. All right, then what did we skip to? 22 through 25? Okay, there are 37 people in this class 7 days ago. Now there are 12. Can I count? Not really. We didn't lose too many. 37 people in this class. Now there are 12. Does the extreme value theorem say anything there? Why? Not continuous, right? That's not continuous. The number of people would not be continuous. You wouldn't go through all the number of people. Plus, you wouldn't have decimal number of people. 37 miles from home 7 hours ago, now 12 miles from home. So what? Is that continuous? So you had to hit every distance at between 37 and 12. You were at some point you were at every distance between 37 and 12 away from home. Okay? All right. I was driving 37 miles an hour. Now I'm driving 12. Is that continuous? Right? You're going to hit every speed between 37 and 12 on the way home. Okay? I have $37 in my pocket. Now I have 12. Not continuous. So you're not going to go through all the different amounts of money or whatever. Okay? So those kinds of questions are the kinds of things we will do. A little bit of calculating, maybe. That's no calculator. That'll be easy calculations to do. Things you can do or should be able to do without a calculator. But understanding these things. Okay? All right. Get out your sample 2 packet. Let's look at that a little bit. And I didn't really give you a chance yesterday to ask questions about that. I would say by the end of today, it would be nice to be getting yourself through sample 2, towards the pre-response, maybe by the end of the period. I'm going to give you some work time here, a fair amount of work time. So it'll be important to use that, unless you're planning on spending a lot of time outside of class as well. But I'm not going to give you any book assignments, so really the only thing is going to be to work. And the more you can get done on sample 2, the better, because we got 2 more packets to do. And, the next one you could pick up today if you want, but, maybe a little bit of work time on that tomorrow to kind of get going on that. But again, probably the weekend, you probably focus on the take-home, those kind of things. As you Tuesday, you're focused on the quiz, so you squeeze in a little bit of packet work. But then, once after we take that quiz on Tuesday, we want to probably be getting into the 4th packet by then. So, so getting ahead of the game here and taking advantage of this time today is going to be important, right? Or you're really going to be scrambling late. And then what usually happens is people just start copying stuff, just write something down, and you get very little value out of it that's going to be helpful on a midterm. Okay? And then you're great on those. So, okay? What do you got? Anybody got something? 6. A normal line to the graph of a function is defined to be the line perpendicular to the tangent line. Okay? The equation of the normal line is, well, the way we do the equation of any line is we do y equals the slope times x minus our x point plus our y point, right? That's how we do the equation of any line. Then we usually do the tangent line, but the normal line is perpendicular. So what's that mean the slope is? If they're perpendicular. Opposite reciprocal. Opposite reciprocal slope. So we do it just like we would a tangent line, but we have to do opposite reciprocal on the slope. So here's the curve. So we're going to need the derivative of that, right? That's how we're going to get the slope. Okay, so y would equal, that'd be x squared minus 1 to the 1/3. So we'll do the derivative of that, which would be, and then it says we're x equals 3. So I already know I'm going to put a 3 in there, and I can probably put my 3 in here to get my y point. 3 squared is 9, 9 minus 1 is 8, cube root of 8 is 2. So I already got all that, right? I got all that I need. Now I just need the slope. Okay, so I'm going to get my slope of the tangent line, which is derivative. So I have 1/3 x squared minus 1 times to the negative 2/3, right? And then times the derivative of the inside, which would be 2x. So that will be y prime. So it'd be 1/3. This would be 1 over x squared minus 1 to the 2/3. And then times 2x. And so now I can plug in my x equals 3. So x squared, so that'd be 9 minus 1 is 8. Now what's 8 to the 2/3? What's 8 to the 2/3? 4. Do the third first. The 3 is the root. What's the cube root of 8? 2, and then 2 squared is 4. So when we put a 3 down here, we get 8 to the 2/3, which would be 4. So this is 1/4. And then we put a 3 in here. 2 times 3 is 6. So this would be 1/3 times 1/4 times 6. So that's what? 6/12, which is 1/2. So do I put 1/2 up here? No, I put what? Negative 2, right? So the tangent line slope is 1/2. The normal line would be negative 2. So now I get y equals negative 2x plus 6 plus 2. I get y equals negative 2x plus 8. And then I look at how these are all written. They have y and x together, so I'll add the 2x over. Y plus 2x equals 8, which would be choice D. Okay, so some derivative practice, a little bit there. You know, and of course, understanding the tangent line, that's what derivative is. Slope of the tangent line, that's what derivative is. So you get the slope, then you got to do the opposite reciprocal because it's perpendicular. Okay? All right, what else? Okay. Now on 20, and again, this first section, this no calculator, and I haven't decided yet. A lot of times we do the no calculator midterm first, so it could be the no calculator one could be first. Scores tend to be a little lower on that one, and maybe it says it's a little longer. Could be because it's got a few more, just more algebra stuff and trig things. Because that's the thing, of all the sections, the no calculator multiple choice section is the one where you got your algebra and you got your trig stuff you got to know and things like that. Okay, so now when you're looking at this problem, you know, you might look at this and kind of get confused by that. To be honest, most of the time you can ignore that. It's probably not a big factor in the problem. But let's just talk about it a minute. This is basically saying x has to be between 1 and negative 1. That's what that's saying right there. Okay, now that's just a domain thing because, so they wouldn't have had to tell you that. It's just obvious from the problem because we know we can't have a negative in the square root. And if x gets bigger than 1, you're going to have 1 minus a bigger number. You're going to have a negative in the square root, or negative 1. Whatever. So that's the natural domain of this is telling you you can't have a negative in there. Okay, so x has to be there. Now, why is that important? Well, because we're now going to do the derivative, and sometimes that restriction goes away. Let me give you an example. Let's just say we had y equals ln x that we were starting with as a function. Now, here's the graph of y equals ln x. Right? What's the domain? X can't be what here? In natural log, x can't be 0 or negative, right? It can't be less than or equal to 0. In natural log, x has to be positive. So for the rest of the problem, if you start with this function and it asks you about derivatives and inflection points and that stuff, for the rest of the problem, x has to be positive, right? That's just a given in this problem. They might tell you it, or they just expect you to know it. That's the natural domain of natural log. Now, what's the derivative of natural log? 1 over x. Well, we just got done looking at that graph. This was the graph of 1 over x, right? Can x be negative in 1 over x? Sure. Can't be 0, but it can be negative. But not in this problem. Not if we're talking about the slopes of this graph, because what are the slopes of this graph? Always what? Positive, right? So we can't, so the 1 over x graph in this problem, if we were working with ln x, we wouldn't have this part of it. We would only have this part of it because of that domain, okay? That's the idea. Now, usually that doesn't become a big issue. It's not something that has to, necessarily be thought of in the problem, but it may. I mean, it may. So I just point that out. But for this one, to be honest, it really is not a factor, okay? What's going to happen, though, when we get our answer is x could be bigger than that, but it won't be because it couldn't be in the original problem. All right, anyway, I would put parentheses around that, but this is ln. Okay, so basically we got to do the derivative. So the derivative is 1 over the inside, which would be square root 1 minus x squared, times the derivative of the inside. Now the inside is 1 minus x squared to the 1/2. So I'm going to do big parentheses like we talked about here, because it's messy, I can see already. So now I'm going to bring down the 1/2, have 1 minus x squared to the negative 1/2. And then I got to do the derivative of that inside. So I need another set of parentheses that would be inside these. And now what's the derivative of 1 minus x squared? Oh, that's negative 2x. So I really, as it turns out, didn't really need these parentheses because I basically have this thing times 1/2 times this thing times this thing. So it's really not too big a deal. Okay? Now I could actually cancel the 2's right now. Okay? Because they're 1/2 times 2. So that'll just be 1. Okay, so now I'm going to rewrite this. So now I got 1 over the square root of 1 minus x squared. And then I got this as a 1 over the square root of 1 minus x squared. Because I'm looking at my answers and I'm thinking, okay, I need to do some algebra to this. And then I got times what? Negative x. Which, how's that look? Did I forget anything? Does that look okay? So I got that. This would be 1 over with the negative power, and then I got the negative x with it. Okay, now when I multiply across here, what's square root times square root? Yeah, it just goes away, right? So we just get that. Now I look up here and I notice that's not any of my answers. So now what? On the bottom, let's take out negative 1, which would turn that into that, right? Which is actually x squared minus 1. And then this negative could cancel that negative. And so now we're going to have x on top. And then the bottom is now going to be x squared minus 1. And that looks like b. So again, a big part of that problem was algebra, wasn't it? Now, you got to be able to do your derivative, right? You got to be able to do your derivative, which is no more than a basic gateway one, probably. Now, it'd be a harder gateway one just because I would have expected you to simplify it as well. Okay, so, but that's... There you go. And so the no calculator section is also where they would test your derivative knowledge, right? Like your gateway knowledge. If it's a calculator one, you can let the calculator do it. That's a nice thing. Okay, so That tends to be why the no calculator one sometimes is a little bit. Yes, Vanessa. 11. Ah, 11 is the new theorem we have to learn tomorrow. So put that one on hold, and after tomorrow you'll be able to go back to it. Okay, which one? 23. Okay. The edge of a cube is increasing at the rate of 0.05 centimeters per second. Okay, so now let's just draw a cube. And it says S is the edge of the cube. Okay, so if we have a cube here, S would be an edge, right? Cube, of course, all the sides are the same. Talks about the volume of the cube, the rate of change of volume, so that'd be V prime, right? So V would be just S cubed, right? And it says the edge is increasing at a rate of 0.05, so that's S prime. So S prime is 0.05, correct? So they want to know V prime. So this would be a lot like the quiz we took last week, right? Did we try you doing that tonight? Okay, so V equals S cubed, so V prime would be 3 S squared S prime. So we can plug what in for S prime? 0.05. 3 times 0.05 is 0.15 S squared. They just didn't give us anything to plug in for S, but that's okay. We didn't need it because if you look at this, if you look at the answers, you know that's something you always want to do on your multiple choice. Is look at the answers, kind of what form are they in. Sometimes that gives you a hint as to what to do. Okay. Oh, then, oops. Okay. Then we got another one. I mean, really, again, the goal, and I want you to work together and talk things through, whatever, but the goal, if you're going to be able to do, you know, good enough to make this a good grade on this midterm, is to be getting through them, and even on your own, kind of be able to do them somewhat too. But, you know, as with each packet, you should hopefully be trying to do more and more by yourself, but ask a lot of questions of your working partners, or ask me. I mean, you can look in the answer book, and maybe reading what they've got in there is enough to make you understand it, but, you know, maybe not. Anything else? Time for one more. Which one? Did you try it? Or does it just look hard? You looked at it. Okay, now, that's a good one. That's a good one because first of all, it's on the calculator part. This is a great example of one the calculator doesn't really help you, right? I mean, just because it's on the calculator part does not mean you use a calculator, right? A lot of times they're written in such a way that the calculator doesn't do you any good, okay? And that's why they put them on that part, right? So the key is understanding what that is on the left side, and what that is the alternate version, and this is one of those things that I've never made it a big deal for you to memorize because it just doesn't show up very often. But if you can remember it, it's better because it helps you in a problem like this. But then again, 65% is an A, so you know what? If you have to miss one because you just don't remember something, you know, you can afford to, right? You can afford to. But this is the definition of derivative, right? Now, why is this the definition of the derivative? Well, what did we say? What is that part right there? It's a good review. What is this part right here? What is that part right there? I don't know if distance distance is the right word. Let me. What does that red fraction represent? Who's it? Slope between what? Slope between 2 points. What are the 2 points? X and x plus 8. It's slope between 2 points. When we talked about the definition of derivative, we broke this down into 2 parts. This is slope between 2 points, x and x plus 8. What does this part make happen? 2 points become 1. As h goes to 0, the x and the x plus h come together. That's what makes it a derivative. The derivative is a slope of 1 point, right? That's the definition of derivative. This part here is slope between 2 points. This part has the 2 points become 1. Okay. Now, this picture, this right here, is the same exact thing with different labels on my 2 points. This is right? Now, what's this part right here? The slope between these 2 points. It's f of x minus f of a, and it's x minus a. Rise over run, subtract the y, subtract the x's. What does this part do? X approaches a. As x approaches a, the 2 points become 1. It's the same thing. This is another way of saying the derivative at point A. This is the same as saying the derivative at point X. Now, you might remember when we first did this, we had an A here. We had f of a plus h instead of f of x plus a. Okay? So this is the definition of derivative we usually use, but this is one as well. It would be nice if you recognize this, and my hope would be, and we didn't do a very good job on that one, my hope would be when you see this, you think slope right away. I mean, that's subtracting 2 y's and subtracting 2 x's and dividing. That's what slope is. So my hope is you would see this as slope, and as x approaches a, the 2 points become 1. That's derivative. So what this is really saying is f prime of a equals 0. So it's not a problem to be worked out. It's just an understanding of what something is, what it means. Okay, and those are not always easy. I understand it, and that's why we do these packets, right? You saw it, we talked about it. So now you might get to see it again, right? Maybe in another packet will come up, and you'll be like, aha, I remember that. Okay, but that's that. Okay, so let's go ahead and I'm going to let you work now. If you would get done through sample 2, if you've been putting some time in and you're kind of done with sample 2, the next one is sitting right up here. Now, and at the end of the period you want to take it, that's fine. I'll probably pass them out to everybody tomorrow. Okay, so if you're going to be gone tomorrow, you want to take one. Now, one thing that's different, the 2 packets you have right now came from this book here. And at the top, they say in great big letters, they say sample exam 1, right? Sample exam 2. This one's from a different book. It has a different answer book. What it says at the top is exam 2. And then that one here says exam 3. So when I talk about them, I'll call them sample 1 and sample 2. Those are the first ones you've got. And then these are exam 2 and exam 3. Now the first 2 I've already given you. Those are the ones that will be turned in the first day we take the midterm. Next Friday. And then the exam 2 and exam 3, these will be turned in that next Monday when we take that midterm. Okay? But you can grab one of these if you want to, and if you're going to be gone tomorrow, you should for sure. And I'll pass them out tomorrow. Okay? So, you got time to work now. This is the time to take advantage of packet time, right? Getting this done so when you get the take-homes and this weekend, you can be focusing on those things. Okay? Get as much as you can done. Answer books are over there. Come up and ask me if you got questions. That's the one I already gave you, that exam 2, yeah.
easier than to do this? Because you can't use a calculator. Like, I was just thinking, would you just plug in X values and see if you get 0?
No, you gotta do the second
Second, okay.
because it's inflection points.
Okay, and that.
Now, 35 over 7 is 5, so that would, if you simplify that, right? So, but, yes, so that's first derivative. Now do the second derivative, set it equal to 0, and then you should be able to solve it. And if you still can't, let me talk.
Alright, so all three of us are gonna gone for second block on next Friday. Is it alright if we come in first block and take the final then?
We're leaving for Central City.
Yeah, sure, because that's what do you think?
Show choir.
So yeah, we leave
What's
at
your
like
first
10.
block? What's your first
First block is choir.
So
Oh, so
yeah.
they'll let you do it.
Yeah.
Oh, that's perfect. Oh, that's perfect. Yeah, yep, come in, we got plenty of room. So come in and do it then.